Dear students, in this session, we are going to see about electrostatics. What is electrostatics? Electro means charge, statics means rest. So, to study about the charges at rest is called as electrostatics. In this session, we are going to see about electric charges and Coulomb's law. Define electric charge. So what is charge? The charge is a inherent fundamental property of the particles which is responsible for the electric and magnetic interaction. Electric interaction means due to the attraction or repulsion of the like and unlike charges, and also the north pole and south pole of the magnet will attract each other. So these are all the attractions or repulsions are because of the natural fundamental property of the material it has. So in order to understand the definition of the charge, now we are going to see about frictional electricity. The friction means the rubbing. Due to the rubbing of the two things, the friction will occur. Due to this friction, the charges are developed. That is called as a frictional electricity. Let us see one small example. When the glass rod is rubbed with silk, so what will happen? The glass rod will become positive charge and the negative silk will acquire negative charge. So how it is happens? Before rubbing, the glass rod has equal number of positive and negative charges. Silk is also having a equal number of positive and negative charge. That means the glass rod and the silk are neutral. So after rubbing, what will happen during the friction? So there will be a transfer of the negative charge. The glass rod donates, it will transfer the negative charges to the silk. That is occurs because of the friction. So the number of negative charges will decreases here. The number of positive charges will increases here. Hence, the more number of positive charge in glass rod, there will be a more number of negative charge in the silk. Hence, the glass rod will become positively charged body and the silk will become negatively charged body. So when the two positively charged glass rod are kept very closer to each other, these two will repel each other. Similarly, when the glass rod and the negatively charged rubber will keep closer to each other, these two will attract. Now we come to the conclusion. The like charges will repulse and unlike charges will attract. Hence, there are the two types of charges, positive charge and negative charge. The single positive charge is called as a proton. We can denote it as plus E. And the single negative charge is called as a negatively charged particle is called as a electron. That is, the magnitude of the one electron is minus E. Let us see the properties of the electric charges. The first property is additive nature. That is called as a superposition principle. Let us assume a small surface which has a n number of charges. Let us say Q1, Q2, Q3 and Q4. So the total number of charges in this surface is merely adding all those things Q1, Q2, Q3 and Q4. So now we will assume that Q1 is equal to 1 coulomb and Q2 is equal to minus 4 coulomb and Q3 is equal to minus 2 coulomb and Q4 is equal to plus 8 coulomb. Let us see that what is this coulomb? This coulomb is a SI unit of the charge. So what is the SI unit of charge? It is coulomb. We should write only in small letter. Coulomb is a scientist name. We should write the unit in small letter, but the symbol of the scientist name will be only in capital letter. Similarly, for force we can write Newton. Newton should be written only in small letter, but the symbol of the Newton N can be written only in capital letter. Yes, you come to our problem. By substituting the Q1, Q2, Q3 and Q4, it is merely a algebraic addition. That is a plus 1, minus 4, minus 2, plus 8. Finally, we get the total charge in this surface is plus 3 coulomb. So that is the additive nature of the charge, merely adding the charges. The next very important property of the charge is quantization of the charge. The quantization means the charges never be in decimal, that is not in a fractional. So it is denoted by equation Q is equal to N E, where E is a magnitude of one charge. Magnitude means value. What is the value of the one charge? One charge value is E is equal to 1.6 into 10 power minus 19 coulomb. So if it is a electron means, minus 1.6 into 10 power minus 19 coulomb. If it is a proton means plus 1.6 into 10 power minus 19 coulomb. This N indicates integer. That means it is a plus or minus one charge. It may either it may be a plus 1 coulomb or minus 1 coulomb, or plus 1.6 into 10 power minus 19 coulomb, or minus 1.6 into 10 power minus 19 coulomb, plus or minus 2, 3, 4. It never be a 2.3 or 4.5 or 2 by 3 charges. That means that is called as a quantization of the charge. Quantization of the charge means only in whole number. Charges will be only in whole number. Now I take the one small example for charge Q. The total charge Q, I will take the 1 coulomb. That is Q is equal to Ne. N is equal to Q by E. So by substituting N is equal to Q by E, Q is equal to 1 coulomb and E is 1.6 into 10 power minus 19 coulomb. By doing this simplification, we get the answer. The number of charges, the number of electrons present in 1 coulomb of the charge is 6.25 into 10 power 18 electrons. Listen, students, 10 power 18 electrons, 10 power 3 it's a 1000, 10 power 6 is a lakhs. So 10 power 18 is the crores and crores of electrons are present in only near 1 coulomb of charge itself. Let us imagine what is a 5 coulomb, 10 coulomb and 1000 coulomb of charges. Then the last property of the charge is conservation of charge. Conservation of charge means the charges neither be created nor be destroyed. It can be transferred from one body to another body. Yes, I will take the previous example itself. In this example, we will say that the glass rod rubbed with the silk, there will be a transfer of charges only occurs, not a new charges will be created. That is, charges neither be created nor be destroyed. It can be transferred from one body to another body, or for an isolated system, for both the systems, before and after the friction, before and after the rubbing of the two materials, the total number of charges are same. Yes, here the total number of positive charge and negative charge, the total number of the positive and negative charge, we have it. Only some amount of the negative charge is transferred to silk. So even though the total, for the total system, both glass rod and silk, before the rubbing and after the rubbing, total number of the positive and negative charges are equal. That is called as conservation of charge. Now we will see another important process is called as electrostatic induction. So electrostatic induction is the process of charging a body without contact. Let us see that the first step, the first diagram shows that it is an uncharged metal. That is, the total number of positive and negative charges are equal in this metal. It is a neutral body. When the positively charged glass rod is brought nearer to the uncharged metal, what will happen? Here the positive and negative charges are present in the uncharged metal. The negative charges are attracted towards the glass rod area, and positive charges are repelled by this positive charges, so it will accumulate in the opposite side of the sphere. So the next what we will do that, if you earthing, so only the positive charge will be earthed. Earthing means it will, all the positive charges will be goes to the ground. So provided we have to keep the glass rod here itself. Then in the fourth step, you see the picture, so there will be a glass rod in the same position. The negative charges only present because these positive charges are earthed. If you remove this glass rod, these negative charges are evenly distributed over the surface of the metal sphere. Hence, the uncharged metal will become a negatively charged metal sphere. Even we can charge this metal by the positive charge also. If you bring this negatively charged rod or any silk or some other things, the same process will be repeated, and finally we get positively charged metal. Thus, you're charging your body without contact, without touching the body. The charges are, this uncharged material is charged. So that is called as a electrostatic induction. Yes, dear students, we summarized all those things. What is your charge? The charge is an inherent property of the particle, and the charge can be defined by using the process is called as a frictional electricity. By doing this frictional electricity experiment, we come to the conclusion there are the two types of charges, positive and negative charges. The like charges will repel each other and unlike charges will attract each other, and finally we see that what are all the properties of the charges. The very important properties, three properties of the charges are additive nature, quantization of the charge, and the conservation of charge.